A parent is pulling her 20-kilogram child on a 2.5-kilogram sled. Along with the horizontal surface, the tension in that rope she's pulling is 100 newtons and is acting on an angle of 50 degrees above the horizontal. There is a 22 Newton frictional force acting on that sled. Oh, brother. Oh, brother. So we know that there's going to somehow be an F of 22 newtons. But also, there has to be force being applied, which is going to be 100 newtons. The child weighs 20 kilograms, and the sled is 2.5. So why don't I say 22.5, and that is going to be kilograms. And if I write that to some kind of so-called proportion. 10 kilograms. And I'm going to say 9.8 newtons, so we try to find how many newtons that is, so we find the weight and the normal force of that sled. So if I find the newtons, I'll have to do that by x, and yes, I'll have to do a calculator, do all that stuff. And not only that, I have to do 22.5 times 9.8, and then I divide that by 10, because that's 10 kilograms, because it made some kind of proportion. So we should, hang on, what? 22.5, and I should multiply by 9.8, then divide that by 10, that is, huh? Oh, hey, Mom. Recording myself so I slow down and just talk my thoughts. That's what I said Yu-Gi-Oh! What I meant is because those so-called Yu-Gi-Oh! Players on the anime talk before they think how to make their move. Oh. Yeah, so 22.5 multiplied by 9.8 is, yeah, 220.5, divide that by 10, 22.05. So that is 22.05 newtons. I'm not posting this, you know.
What's that?
I'm not gonna post this, you know.
I don't care, I'm just getting your socks.
Oh, thanks. And that should also mean the F norm should also be 22.5.
You might want to put your sheet back on.
I know, I forgot to make my bed.
Well, no, I'm saying your sheet would be a lot more comfortable if you get that back on.
If I do that so-called right triangle, draw and label the force of a free body diagram, which we kind of already have. Calculate the x and y components of the tension force. The what? I kind of wish this was rephrased, because what do you mean by tension force? The force of that sled is 100 newtons. How do you calculate that? It's in the thing. Calculate the net force acting on the sled / child. Huh? Calculate the net force acting on the child. Rephrase this again, please, because I don't get it. If the net force is 100 newtons, calculate the acceleration of the child and the sled. Okay, so now there is something that we can solve. Calculate the acceleration. Wait. I wasn't supposed to convert it to newtons. I should have kept it in kilograms. So what I have to do now is keep it back to 22.5 kilograms. So our F net is going to represent our mass times our acceleration. We want to find the acceleration, but we don't have the A, but we do have mass as 25 kilograms. And we also have the net force is 100. So here's what happens. 100 equals 25 kilograms times A, 25A. Divide by 25, divide by 25, And the sled should be moving at 4 meters per second. Looking at the vertical forces, what should be the normal force, less than or equal to or greater? I would say equal to, because the force needed to keep sled up as weight. And yeah, we're done. Remember, this video may be incorrect. Therefore, do not use this as actual math. This is just people with ADHD trying to think out their thoughts. Thank you.